Well, hello everyone. Welcome back to Adrian's Digital Basement. For today's video, we're going to be revisiting the IBM PCjr. Wait, this is not a PCjr. This is a PCjr. It's actually a contemporary of the Commodore 128. Both these machines came with 128K stock. Well, actually, this is 64K, and there's a 64K expander, which brings it to 128. But it's time to revisit this thing. If you remember from my last videos on this, I bought this thing pretty cheaply, and it turned out that the floppy controller card had a bad made controller chip that would result in unreliable floppy drive operation. That's since been fixed, so this thing at least boots reliably, but I found that 128K in this machine was just relatively useless. When the PCjr was released, IBM envisioned that you would plug sidecars into the machine for expansion. And here's an example of a sidecar. And what this does is you remove a panel on the side of the machine and you connect this up, and you can stack multiple sidecars to the machine. You just pop the little plastic cover off the side, and when the machine's turned off, you plug the sidecar right into the side of the machine, and then there are screws that hold it on. And then you take the plastic cover that was there and you put that onto the sidecar, or you can stack additional ones on there. Now I have to give a shout out to one of my viewers, Jared, who sent me this sidecar. This is a Tecmar JrWave, which is actually an expansion memory sidecar for the PCjr. He sent this to me with the caveat that he had no idea if it actually worked or not, but I was willing to try anything since the PCjr was kind of useless without it, and Jared also included a bunch of other ISA cards in the box when he shipped this to me, so thank you very much, Jared. So I popped the cover off on the JrWave. Let's take a closer look. Now if you see, this has what looks like a large heatsink on here. Now it is screwed in, but it's not attached to anything anymore. Because originally this had a voltage regulator on here with an AC power supply. So there was some bridge rectification and other things going on. And I had quickly adapted this board by just removing the voltage regulator and rewiring this so I could just plug 5 volts DC directly into this. Now the reason for that is the built-in power supply on the PCjr is relatively inadequate to support sidecars that take a lot of power. Now looking at this, you can see the RAM chips here are only partially populated, and you'll notice that it looks a bit strange the way they're inserted. I couldn't find any documentation whatsoever for this card when I got it, so I've actually sort of reversed how the card works. These dip switches here control the memory configuration on the board. This board actually supports up to 640K, meaning you can put 2 banks of 256 on here and then an additional 128K. If you happen to have one of these cards, I've created a picture which shows exactly how the banks are all configured and the dip switch configurations. In my opinion, it was kind of crazy how they designed the banks. Why weren't the banks together in chips of 8? And there was no silkscreen labeling of any kind, so it took me quite a long time of tracing out the board just to figure out this strange configuration. Anyway, needless to say, unfortunately this board does not work. There is some kind of a problem, as far as I can tell, with these PAL or GAL chips here, the ones with the labels on them. What happens with this board is when I populate it with RAM, and currently I think it just has 64K of RAM on here, is the computer sees the memory perfectly, and in fact when you turn it on it counts up the memory, it looks like it's going to work, but once you start to use the computer it starts to crash. As far as I can tell what's happening looking at the oscilloscope, this board is not refreshing this memory correctly. And DRAM chips need to be refreshed or the data that's stored within them starts to kind of fade away. Happens relatively quickly, but it's not fast enough for the RAM check to fail when you first turn the computer on. But if you load DOS into the high memory and you start using this memory, it starts to crash very soon. I found a memory test utility that allows you to test the memory over and over again. It writes to it once and then it keeps reading it back multiple times. And the more iterations of the test I run, the more errors I get. So anyways, after much troubleshooting, I've decided that this board is really not worth fixing. In case anyone's wondering about the troubleshooting, I have replaced all the TTL logic with new versions, so just to make sure that none of those were causing the fault. But definitely the refresh comes from these PAL or GAL chips, whichever they are, and that seems to be where the problem lies. That leads me to this stuff here. Let's take a look at what I have in front of me. This is the main attraction in this anti-static bag. When we open this up, what you see here is a Junior IDE Rev B board. This board is pretty spectacular when it comes to expanding your PCjr. In this bag we have a big warning message, and what this is a power supply. And this is a new power supply for the PCjr that essentially is an all-in-one IBM power supply, serial number 8, and in the same spot as the old input jack that was AC on the original PCjr, and on my new PCjr I have that micro ATX power supply. It now takes the standard figure 8 connector, and here's a Yankee plug, as Dave Jones says, but you can put up to 240 volts into this. So this is not being sold right now apparently, because the issue is this here is all high voltage. This is mains power right there. And of course it's very dangerous. You know, anyone could have this plugged in and not think and just grab this to pull it out. What I'm going to do is I'm going to put a little bit of plastic on here to make this a bit safer to use. And last up is we have another sidecar. So what this is the IBM parallel port sidecar. And the reason why this was sent along is, as you can see, the Junior IDE has no case. It's just the bare board. But I got this sidecar to basically gut and take the parallel port card out and then put this into there so that it's nicely enclosed in a case. Now, all of this stuff here was graciously donated to the channel by Alan at retrotronics.org. I'll be definitely putting a link in the description. Check out his website when it comes to PCjr stuff. He sells this stuff. You can buy these fully assembled boards from him, but do keep in mind that this power supply is currently not available due to the safety issues because of the 120 volts. So you can ask Alan about that to see when he's going to have these for sale, but just know that currently you can't buy these. All right, let's take a look at the star of the show, the Junior IDE board itself. So I'll bring up my phone here, and this gives us a little idea of what this board is capable of. It essentially gives your PCjr a 40-pin parallel ATA interface, which you see right here on the end. My finger is touching it. We get 1 megabyte of static RAM. So these static RAM chips here mean that there is no DRAM refresh needed for this memory, so there won't be any issues like I'm having with the other board. We also get 512 kilobyte of flash ROM. Now keep in mind that's probably more than you're ever going to need on the PCjr. It won't even map into the address space. What the ROM is used for now is allowing the machine to boot from IDE, but it's flash memory, so that allows you to customize it and do whatever you want and change it relatively easily. Very cool. Going back to here, we have a real-time clock, which is down here. It's a CR2032, it's not populated. And there's a power on self-test post display. That's these 2 digits here. That allows the machine to give you some diagnostic codes if you're not getting any screen display when you first power it up. And you get some bus activity LEDs. It seems to have 2 Atmel chips here, and as far as I understand, I think this is a CPLD that essentially is doing all the heavy lifting of everything you saw on that Tecmar card that interfaces the ROM and the RAM into the bus itself. Now, there's another Atmel chip here, probably another CPLD. I'm not totally positive on what these do, but you can definitely check out Alan's website at retrotronics.org to find out more about the design of this board. If you have a PCjr, you must go check out the forums at Brutman.com. His PCjr forums are the authoritative source for all information about the PCjr, and there are of course large discussion threads all about this card there. So let's talk about the IDE interface on this board. So clearly the PCjr has no provisions for an internal hard drive. It doesn't even have a power connector for one. But what you can do is use something like this. This is a compact flash to IDE adapter, and essentially compact flash cards are just IDE. So there's actually no chips on here if you notice, there's nothing on here, because it's just passing through from the different connector into IDE. And this should actually connect straight up to this board and hopefully fit within the sidecar, or maybe it'll stick out the back, but that's fine, that'll allow me to, pull this card out of there if I need to. Now, some of these compact flash adapters support being powered off an extra pin on the IDE port. This one doesn't have any jumpers, so I'm not sure this one does. Obviously it has this. I can probably just run from the 5 volts from here straight over to this 5 volt pin on the board, and that would actually allow this to be powered if it doesn't work straight off the connector. But he has right here JP1, and it says 5 volts on pin 20, and this is the power pin that I'm talking about that could power this up. So I'm going to set this jumper, and it may work as is, but if not, then I'm just going to have to run 5 volts from here onto this power connector. So Alan graciously donated this parallel port adapter to me, so see the opening on the end with a parallel port, but I actually don't have one of these, and it would be useful to actually use a parallel port on the PCjr, say I wanted to run Print Shop or something. So what I think I'm going to try to do is I'm going to try to reuse the sidecar case from this Tecmar memory card, which I'm not going to use since it's broken, and it hopefully should fit in this. I think this is all pretty standard the way the screws are and whatnot. So this board would just lay in there like that, and yep, sure enough, this seems to fit. And then this would just clip on like that. So yeah, this works, and check it out. On the back here, you have the compact flash card. As long as I maybe hot glue or put a little bit of glue on the adapter so when I pull the compact flash card out, it doesn't pull the whole adapter off, this should work. And yes, it does need a little retro bright, so I'm going to need to do that. But then what that means is I can take the parallel port sidecar and then I can daisy chain this together, and then I can get a working parallel port for the PC Junior. So first off, we need to test this out on the PC Junior before I put it all back together. So I stuck a CR2032 battery in there. All right, we'll just move the side cover out of the way, and we are going to just push this onto the PC Junior. Make sure it's off, of course, when you do this. There we go, it's on there. I think one thing to consider, and I haven't read the documentation, is that the built-in stock power supply on the PC Junior may not be powerful enough to run this. If you remember from my early videos on this machine, I never got the big AC brick that was external to this machine to run the stock power supply. So I took that power supply out, and this is running a micro ATX power supply, and currently there's an external 12-volt brick that powers this thing up. So that new power supply has plenty of power to power up any additional cards like this, so I'll have no problems. There is actually DOS 6.22 on here, although I don't think that will boot. You can't just boot DOS 6.22 on this machine, not without patching it. Although, again, I'm a PC Junior noob, so that might not be correct, but let's turn this on. Okay, we're getting postcodes. We have F3 shown on there. We get the IBM logo, but the PC Junior might count up to 640K. That's the most amount of memory that it can see using the stock RAM check here at boot. Alright, so it's showing the memory. The total memory is 736K. That's the most the PC Junior can actually support. I hit escape for a boot menu. So I hit escape for the boot menu, and we have A for floppy disk or C for basic or cartridge. It's not detecting the hard drive because I don't think power is getting through to it. So let's hit A. I closed the floppy drive. I think I have a boot disk in there. Well, anyways, that was pretty damn easy. So I think I'm just going to hook 5 volts up to the compact flash card, and this thing might just potentially boot. If you notice there at the boot screen, it's using code from xt-ide project, which will allow large format compact flash cards or disk volumes to work. This drive is formatted for DOS 6.22, so it has 2 GB partitions. But like I said, again, I don't know if that'll just boot on this machine without some type of patching. But we'll find out once I get this working. I simply just ran a jumper from the top pin on this power connector here, which is 5 volts, to the aux 5 volts pin right here on the board. We still have no luck, so maybe I gotta do a little investigation. Time to get the multimeter out. Okay, so Adrian Black is a dummy sometimes. I didn't even look to see that pin 1 is down here on the Junior ID, and it's up here on the adapter. So I need to switch this around. I had it plugged in the wrong way. Alright, so now this is plugged in the correct way. Yes, pin 1 is down here, pin 1 on this card is like that. So it does sort of plug in upside down. So this blue wire you see here, this is the 5 volts. I just bent the little pin over so it's now flush. Let's take a look at the compact flash cards. So this is the one I was trying to use, the InnoDisk. I think these are industrial compact flash cards. I've had really good luck with these. This is a 4 GB card. These work really well on newer machines. I actually was using this on a Pentium machine with no issue. This is formatted with DOS 6.22 and everything. But I have found on some of my older machines, like the 5115, 5160, I think maybe the Tandy, when I try to use this card and I have a couple more of these, it kind of freezes up and just doesn't work properly. So I have an assortment of other cards I got also all from China. So I have these 1-favors, a 4 and an 8 gig, and I have these 2 compact flashes, 2 gig and 512. I think they got these from AliExpress a while back. But let's just pop one of these in and see what happens. Let's try this 512 card here. Alright, so I'll pop the 512 in, just align it correctly. There it is. Oh wow, okay, so it says CF card. So it's, like I said, these cards are really generic, but it definitely saw it. No, it says BIOS installed now, so that's cool. So I think this is DOS 211. Oh yeah, look, okay, cool, it's seeing it. So 995 cylinders. I think DOS 211 supports hard drives, but only up to 32 megabytes. So I had to see what version of DOS I can run on this and see which one supports the large format. Alright, so after doing some research, it turns out DOS 4.0 can run on the PC Junior without being patched, but I tried using it and I had some trouble booting off the Junior IDE. It just sort of froze at boot time. So I decided to try DOS 5.0, which does require patching. I've put links in the description below on the forum post for seeing on how you can patch it yourself if you use the debug command in DOS. So here's my 512 megabyte compact flash card. What I did is I put this on my test bench, which has a compact flash reader, and using a DOS 5.0 installer disk, I set this up with a 512 meg partition and installed DOS onto here. Once that was done, I used the debug command and I followed the instructions on the forum post to patch the boot sector. That does some remapping of the memory map in the PC Junior that allows DOS 5.0 or 622 to use all the expanded memory and actually boot. Okay, so the parallel port sidecar is on here, but it's the inner one that is the Junior IDE. And I just have to carefully slot in the compact flash card. There we go. Alright, here we are. We're booted off the compact flash card. So we have version 5.0 of DOS. And here I'm running the junior config.sys file, and what this does is it configures the memory and allows DOS to see all of it. Now what it's doing is it's taking the low memory that's slow because it's shared with the video RAM, and it's using it up, blocking it from DOS so DOS won't use it, and actually turns it into a little bit of a RAM disk. So even though I only have one partition configured, if I look at the D drive, this is the RAM disk. There, just says junior config. That just gives you a little bit of temporary space. So DOS has seen 753,000 bytes of total memory, but remember, like I said, that lower 128K is used up. So DOS sees a continuous 604,080 bytes free, which is not bad. That's a pretty good continuous block of RAM available. So looking at configsys, you have to start with stacks equals 0, 0, and that's because DOS 5 and up replaces the keyboard handler as it loads. And unfortunately on the PC Junior, it uses a non-standard keyboard controller. It's not the same as every other PC. So if it loads the keyboard handler, you won't have the ability to type anymore. So stack 0, 0 prevents that from happening. Then I have buffers and files, and then here's the junior config line that is configuring the memory. Check the documentation out for this program to see how you want to configure these, but these are the settings I settled upon. And in my auto exec, I'm running the RTC command /D, and that sets the DOS clock and date from the real-time clock on a Junior IDE. It seems to have no problem dealing with the current time and date, which is nice. So I mentioned a moment ago the compact flash card is configured as one 512K partition. And the one issue you run into is when you do a directory, DOS likes to count up the free space that's available, which is what it's doing right now. And it actually seems like the computer freezes up. And there it is. That's showing the free space. Now when you type directory again, it won't be so slow. See, it happens immediately. So if you want to avoid this problem on your PC Junior, create smaller partition sizes for at least your primary C drive. Perhaps you can make it 80 megabytes, which is probably more than enough for most programs. And while it will still take a little bit of time to count up, it will take a lot less time than this. So what I recommend doing to avoid the really long wait for the directory listings is create a batch file that when you type something like ls, you're actually doing the equivalent of dir/b, which is a bare directory listing that doesn't count up the free space. And you can see here, in my main C drive, it lists pretty quickly. I'll go to utils, type ls again, and we get the directory listing without that long wait. If I type dir, it will list everything, but then it's going to sit here and do that slow 47-second count up. So if you recall a moment ago, I said that that junior config.sys file reserved that lower part of the memory for a RAM disk. And what happens is the video memory on the PC Junior is shared with the main system memory with that lower 128K. Even the very first 5150 had an ISA video card that had dedicated video memory. So there was never any contention between the CPU and the video display controller. But on this computer, they are shared. So that has the side effect of really slowing down programs that are running in that shared memory space in the lower 128K. To illustrate the difference in speed you get between running DOS and programs in that shared 128K versus when you use the memory manager to run DOS and programs in the memory expansion card entirely, I've booted up to DOS 2.1 again, and I don't have the memory manager running. Let's run the MIPS benchmark here and see how fast it comes back. We came back with an overall performance of 0.55 or 55% of the speed of the original IBM 5150. Both this machine and that run at the same clock frequency, but like I mentioned, the 5150 doesn't have that shared memory contention issue that this machine has. Let's reboot on the compact flash card and load the memory manager, run this benchmark again, and let's see what we get. So now we're running in DOS 5.0 with the memory manager installed, and if you notice, we are now getting a relative performance of 1.05 versus the original IBM PC 5150. So while we've improved the performance a lot on this machine, I want to improve it more, and I'm going to do it with this. This is an NEC V20 processor, which is a drop-in replacement for the 8088 that's in here. It's easy to find these on AliExpress and eBay for just a few dollars shipped. While I have the lid off to install the processor, I figured now's a good time to install the new power supply in the machine as well. So I just tried putting this power supply in the PCjr and it wasn't turning on, so I did a little testing, and unfortunately this toggle switch is bad. When this is set to the up position, it should be turned on versus the down position, but on the up position, unfortunately there's no continuity between the pins. Yeah, I'll need to talk to Alan about getting a new switch. It seems to operate fine. Alright, we're running on the new V20. Here's the 8088 processor I removed from the computer. Let's see what kind of performance increase we get. So according to these benchmark numbers, we're getting actually a pretty substantial improvement. Some of these, like register to register and integer instructions, are about 2 times faster with this processor versus the old one, and an overall relative performance of 1.40 compared to the normal IBM 5150. That's not a bad improvement whatsoever. I wonder if the dir command is any faster now. Unfortunately, it's not any faster. We're getting 46 seconds to do the dir and the free space counting, and originally it was about 47 seconds. Alright, so this machine is working well. It's booting off the compact flash, it has full RAM available, it's running faster thanks to the V20, but that leads us to one small issue with the PCjr. The problem I've noticed is that because this computer uses a non-standard way to interface the keyboard to the machine, if the application you're running doesn't use the BIOS keyboard routines, then the keyboard entry doesn't work. Let's take a look at Print Shop. So this is a great app for printing your greeting cards and whatnot, and as you can see, this program is working fine. I'm able to navigate around through the menus and whatnot, and nor not having any kind of problems. If we look at the program The Draw, the program seems to start up without any issue. This is a really cool ANSI text mode kind of drawing program. It's good for designing cool graphics that you would display in DOS. Well, when I hit enter and I try to type anything, all I ever get is these equal signs. Basically nothing I type does anything except for that. You can't even press Control-Delete to exit out of this program. It's just stuck here. So I have to use my hardware reset button to get out of it. Another program that doesn't work well is Check It. It's just a diagnostic program I love to use on various machines just to see what kind of performance you're getting and maybe some other parameters about it. Well, this one shows the splash screen without any issue. Hit the space bar. It loads up the information here. So it's running on an IBM BIOS, etc., etc. And you go to hit another key, nothing. So at this point, the program must replace the keyboard handler with its own. And again, you can't Control-Delete out of it either, so reset button is the only way out of it. Well, that's it for my video on the PCjr. It's about as good as I ever want to get this machine. It's basically pretty darn functional at this point with the compact flash card and the extra memory. Yes, I showed a few programs that don't work with the keyboard thing, but I tried several others and they seem to be working fine. So it's kind of a cool little machine. It's much more compact than breaking out my old IBM PC 5150 or 5160. Those things are just so heavy. It's nice that this thing is small. And of course, I kind of like the wireless keyboard actually. I find this kind of useful. I don't have any problems with interference, and it seems to work quite well. So now I want to talk about whether I recommend this machine if you're just getting into 16-bit DOS computers. I'm gonna have to say no. While it's a cool form factor and it's kind of a strange little beast that IBM made, the incompatibility on it is just a little bit of a pain in the butt. I think you're much better served if you look for a Radio Shack Tandy 1000 machine. If these are available in your country, I really recommend getting one of these. This Tandy 1000EX is one of my favorite machines. It's so small and compact, being an all-in-one design, and mine luckily has the memory expansion, so it has 640K, and I've switched out the 5¼ inch disk drive with a 3½ inch. But the nice thing about these is they boast 100% PC compatibility, so you don't have those issues with some pieces of software not working. And not to mention, this is sort of a clone of the PCjr, so it has the same type of graphics capability and sound, but it's actually a little bit better because the graphics subsystem on this doesn't slow down the computer dramatically if you don't have the memory expansion. These Tandy 1000 machines also run at just over 7 megahertz, so they're actually quite a bit faster than these machines, and even better when you upgrade them to a V20. Not to mention, far more games were designed for the Tandy 1000 in mind and don't actually work on the PCjr, not at least without a patch to the game or some mods to your PCjr to make it more like the Tandy 1000. I have some videos I've made on this 1000EX, and I'll put the links to those videos in the description below. Anyhow, if you have any comments or questions on this video, put them down in the comment section below. I'd appreciate a thumbs up if you liked it, or you know what to do if you hated it. Thumbs down. Hit that subscribe button for more videos, and thank you for watching. Bye.